Hey everyone, welcome to CTF Radio. I'm Adam D, and I have with me the awesome Zardus as always.
Hey Adam, how's it going?
I'm doing good, man. So today we actually have a very special guest on today. We're going to be talking with one of the other Order of the Overflow organizers. So for those, why don't you tell us very briefly about Order of the Overflow, just as context, Jan?
Sure. Adam and I love Capture the Flag. We've been playing Capture the Flag, competing in Capture the Flag competitions.
I mean, silly people are listening to us talk about CTF, so I
Exactly.
hope that comes across.
We have a CTF podcast, and one of the major CTFs of the year, as everyone knows, is DEF CON CTF. DEF CON CTF is a giant spectacle and this sort of event that determines the top hackers of the world. They get leather jackets and black badges, and they can walk around feeling very cool. The organizers of DEF CON CTF put in enormous amounts of effort, and it's very taxing. So organizing teams take on 4 years to 5 years of competition, of organizing the competition, and then they retire and pass the torch. When the previous organizers of DEF CON CTF retired, we decided to create the Order of the Overflow. This is our logo. We're all wearing these shirts. We even have hoodies. It's all great stuff.
It's not a fashion show, so let's.
Exactly. So we created the Order of the Overflow to take on the torch and host DEF CON CTF.
And so, roughly, who comprises the order? If you had to kind of, without giving individual intros, I'm sure over time we'll talk to more and more people.
Yeah, absolutely. So the Order of the Overflow includes a lot of people for whom CTF has changed or shaped their lives. It includes huge amounts of us professors that got our start in CTF back in our graduate studies, usually Santa Barbara. It includes industry experts working in industry with the cutting edge of cybersecurity. It includes...
and somebody would say industry people who actually know how to deliver software.
Exactly.
That works. That's not a research prototype.
It includes about 10, 15 people, and you can go to our website, overflow.io, and see our philosophy and the team listing and so forth. But it includes a lot of people that just love CTF and love creating challenges for the best hackers in the world to tackle.
Awesome. Great. So yeah, on that note, thanks for that great introduction, Jan. So we have one of the members of the Order of the Overflow that has been with us since the beginning, I believe. So today we have his hacker alias is Kaptain. So today we're very excited to introduce and to talk to Alexandros Kapravelos, Dr. Alexandros Kapravelos.
Captain?
Sorry. Captain? Yeah.
Captain.
Kaptain? Are you trying to say that silly Unicode character in his name that nobody can say? Yeah, I don't know what. It's some Greek character that.
It's a pie.
Yeah, it causes problems when we are in Discord and we have to. So yes.
It's a way not to get pinged on Discord for anything.
That's
Nobody
great.
can find.
You should use that with email addresses. Just have an email address that has a non-Unicode character in it. So Kaptain is here with us today. So let's give him a round of applause, Jan.
Welcome, Alex.
Yeah, thanks for joining us today, man.
Hey, Adam. Hey, Jan.
So maybe as we can start, maybe you can give a very brief kind of. So the goal today is we're going to talk about one of the challenges that you wrote from DEF CON 28 CTF, which happened in 2020, specifically the finals event. Before we get into that, though, I think people would really enjoy hearing about. Could you talk a little bit maybe about how you first got into CTFs? I think that's like a good starting place, and then we can kind of dive into the Node challenge.
Yeah, so I started playing CTFs basically when I started doing my PhD at UC Santa Barbara. So I got involved through Giovanni Vigna's class to play ICTF, which was part of the homework back in the day. And I started playing CTFs then, and then joined Shellfish and played for multiple years with them up to 2015 when I graduated and left and became a professor.
Awesome. So before that, did you have any experience in CTS before you came to UCSB?
I played a few of them, but not very seriously, and they were all very local, back to Greece or European ones.
Cool. Awesome. That's very cool.
I bet
Cool.
the Unicode
So then-
characters weren't such a problem there.
Unicode support, I hear, is much better over there than over here. But they have their own set of problems, right? You have to still speak Greek and all that stuff. So
There you go.
cool. So then, then let's dive into this DEF CON 28 Finals CTF Challenge. Node. So I'm going to call it from here on out Node, but just for the people listening, the Order of the Overflow has this, some would say beautiful commitment to a comedy bit. Others would say this very annoying habit of adding 3 O's in the place where there should only be 1 O. So for instance, Node is, what was that, Jan?
Some people have no taste.
Yeah, see, there you go. I agree. So yeah, we, if you're going to do something, commit to it, right? Yeah. So we're the OOO, and we do our best to make that happen. So Node is stylized with 3 O's in it. And so why don't you take us maybe through, maybe describe first, what is the challenge Node? Like at a very high level, what is the service, if you were trying to explain it to someone?
Right. So the service at the high level was basically a web application where you get a randomized pirate map that shows where the treasure is, and you can mess up with some of the configuration on the clients on the server side.
Mm-hmm. So it's a web application, right? I mean,
so it's a web application built on top of Node.js by using
hence the name.
Yeah. And by using the Express module, the web framework called Express. The very nice thing about this challenge was that basically you can validate this configuration by making HTTP requests, and this way you can exercise some of the functionality on the server side, which can be abused by the attacker.
Awesome. Cool. Great. So normal website. What's the normal functioning of that website? So
the normal functioning was basically to play a little game where you have the map is randomized, and you have basically to click to find the correct treasure, pretty much.
Okay. Cool. So kind of like a reverse Minesweeper.
Yeah. Yeah.
To interject, there's several philosophies of CTF challenge creation. One philosophy is you start with a cutting edge vulnerability, and you build a minimal service that is just functional enough to have this vulnerability, just to truly expose the vulnerability, so that it is the thing that the hackers playing your game focus on, right? That are trying to hack this challenge. The other style is you write this complex challenge around a concept that you want the hackers to explore before they can find the vulnerabilities. That's usually used more for a concept that an organizer likes, rather than a vulnerability. If you like the vulnerability specifically, you tend to write smaller challenges that exhibit it, or the smallest that can exhibit it, so that people don't get lost on the way. They can just focus immediately.
Or get lost immediately, depending on where they are. Yeah, we've all been on each side of that coin. Exactly. Where you're staring at 20 lines of code and being like, why the heck do I not understand where this bug is? It's particularly web challenges. I think really hard web challenges are similar in that respect.
I think specifically web security challenges actually pose this great challenge that it's not very clear what you should be looking for when you're trying to tackle them, right? So it can be very frustrating that you look for a couple of hours on a web application and you don't even know what the vulnerability could be. And I think that's one of the most devastating thing about when you play CTFs is to looking at something for hours and not even understanding what this is supposed to be. And with web security, with some categories in CTFs, it's they're inherent into the challenges what the attacker should be doing. Like you have to do a portable, you have to do memory corruption, or you have to gain execution, right? The target is very clear.
Or reverse engineering,
webs,
I feel like is
reverse
also a
engineering, the
similar
same thing, right?
like,
you need to understand how these things work in order to move forward. With web security, it could be anything, right? So it could be a SQL injection, or it could be a command line injection. It could be a web application logic vulnerability, or a web server misconfiguration. So you have to start looking into all these branches of different decisions that you need to make on how to tackle the challenge, which makes it really difficult from a design perspective, how to design something like that doesn't it's not fun for anybody to keep looking for something and then find the vulnerability after 8 hours and then exploit it in 10 minutes, right?
Although the flip side of that is the nice thing that I think I really like about CTFs is that it does force you to go out and learn new things, right?
True.
So,
Yeah.
one of the classic things when you're stuck is to be Googling for the latest Black Hat talks or DEF CON talks or whatever about, white papers that people have written about different kinds of vulnerabilities, trying to see. And then it's a very nice exercise to see, okay, can I quickly synthesize what this paper is talking about? And does this fit my current problem? And if not, you kind of throw it away and move on. I mean, I've definitely come across that in prior CTFs where it was about bypassing JavaScript firewalls using Unicode characters that got adapted in weird ways. And, coming into that challenge, I knew absolutely nothing about any of that. And then, towards the middle, you start to realize and you find the Black Hat talk that this has kind of inspired this thing. And all of a sudden you're throwing snowmen and all this other stuff into your URLs and seeing crazy stuff happen that you'd never thought of.
Yeah, and I think the key thing is, what do you want the competitors to take away? Do you want them to learn the concept around which, and Adam, I mean, we'll talk about your challenges in the future as well,
Sure.
but I feel like you tend to move to that. You want the competitors to take away some computing aspect, like some aspect of computing in general, rather than cybersecurity specifically, but with, of course, cybersecurity implications. And whereas this other style is, you want the competitor specifically to focus on the cybersecurity aspect.
Right.
I think both of these styles have their space. They're both super interesting in terms of the different way they force people to learn.
And nothing's perfect. I think that's the other thing, right? There's always trade-offs. Like, I don't think you can design a perfect CTF challenge, right? There's also, we won't get into it now, but there's also the notion of, well, what about exploiting end days, right? That can actually be kind of fun to write an exploit for a production, Chrome, if you take of a known vulnerable version and spin that up, and that's the challenge. That definitely exercises security skills, right? It's just, maybe it's different skills, or maybe it's different kinds of things. So yeah, there's the design space of CTF challenges is vast and super interesting. Cool. Okay, so then back to Node. So we have this website. We're going to this website. What did the teams have access to? So maybe we can help walk through it a little bit from the players' perspectives.
Yeah, so the teams had access to the full source code of the web application. So they could see basically the Node.js code that was running on a web server, and they could poke this service from the outside, right? So they could initiate basically its request and start interacting with the web application. But they had access to the source code itself, so they could go through it and see basically, oh, it's accepting all of these different paths, for example, in the Express web framework.
Yeah, great. And that's, I think, a good thing to always keep in mind. And I don't know if, and maybe at some point we can get Orange from HitCon on here. That's kind of the first time during the HitCon CTF quals challenges that I've seen where you go to a website, and up to that point, all web challenges were basically black box. You're trying to poke it and see what you can do. And so you have this list in your head of all the things you're going to try. And that was the first time I saw a link to view the source, and you view the source and you're like, huh, I understand every line of this and I still don't know how to exploit this. so there's something I'm missing, right? Or another way of often maybe CTFs will have the first step of exploitation on web is usually like a local file inclusion or a local file read vulnerability that you can use to then extract the source and then go further and further. So yeah, I think that's important to always think about both as a player and as an organizer is, like you said, Alex, is okay, what information am I giving the players, right? So in this case, in Node, they had the source. And so can you talk about what kind of that source looked like a little bit from?
It was basically a default installation of the Express web framework,
And was
which
it small?
actually that's a super interesting thing. And what's actually it's one of the two inspirations that I had for this challenge was that if you initiate a new project, and this is how you build Express web applications, right? If you go and you just initiate with the default tools and the default configurations an Express web application, you get a gazillion amount of dependencies installed. If I remember correct, the number, it was in the order of 230 something uh, different Node.js modules that were installed in the local directory in order for Express to be able to just load and have a website basically up and running that does hello world.
And if I
Right.
remember correctly, so I definitely know that this is kind of on the cutting edge of research, right? There's research people have looked at kind of this exact problem that you're talking about, of this, in some sense, dependency hell of Node.js ecosystem, right? Where you include a package, it includes 5 packages, each of them includes 5 packages. And all of a sudden, like you said, to get a hello world web server going, you have 230 packages installed. And I think if I remember
Exactly,
correctly, you actually have research in this
Yeah,
problem
we
as
have
well,
a
right?
paper published at RAID this year that is all about reduction of dependencies in Node.js. So we built a system called Mini-Node that we basically
Mini node,
examine.
tiny node.
Tiny node, yeah. We examine how many dependencies it has, and we do some static analysis in the code, and we say basically, hey, all of these dependencies, they're not needed. We can just remove them. And actually, one of the cool things about that project is that a lot of these dependencies eliminate the whole classes of access, right? So you can basically say this application doesn't have any file system access, right? You can just remove the file system module from Node and
Right.
make it inaccessible so that you basically protect the application from having an injection later and reading a flag.
And you can even see things like npm that do this, that keep track of
Yeah,
vulnerable versions of software, and you can run them on your Node bundle, or I can't remember if it's a bundle or whatever your Node thingy is,
yeah,
and it will tell you that, hey, you should update these because these are known vulnerables.
GitHub emails you automatically about this now.
Yes, the
yeah,
Dependabot bugs me about old 2017
It's
CTF challenges.
yeah. So Node actually has a vulnerable, one of the dependencies that I manually put there was a vulnerable dependency that had a pollution vulnerability, prototype
Prototype
pollution,
pollution.
yeah, prototype pollution vulnerability that happened a few days before the competition started, and I saw it on the vulnerability reports, and I said like, that's an excellent additional dependency that I should put there for them to have and take a look at. And it's public information, so I think that's also pretty cool that you can basically take a look and see that there are dependencies that you have, and when you have 230 dependencies, some of these are going to be vulnerable, and the probability is pretty high.
Right. Cool. Okay, so that was your first. So you mentioned, I think inspiration is actually a great thing to talk about with CTF challenges, right?
Yeah.
Because they don't, despite how it seems, we don't just go, oh yeah, here's the CTF challenge, let me just sit down and write it, right? We need actually some inspiration, like Jan said, about either the vulnerability or the style of challenge, right? So you had one inspiration that was about this kind of dependency explosion, let's say, in Node.js. So what was the second one? Or some other one?
Yeah, so first, both Mini-Node and installing Express by myself is a good inspiration, right? Of observing how dependencies work in the ecosystem. The second one was actually, how in the past I've done also Node.js challenges for
Mm-hmm.
DEF CON CTF, and they backfired a lot because they're pretty hard to contain. So this prototype pollution that you infect basically some variable, and then this infected variable basically propagates and remains in the JavaScript namespace and can mess up with things, have bitten us in the ass in the past, and it has made it.
Why don't we take a detour and actually talk about that? Because I think it's a super interesting tidbit of DEF
Yeah,
CON CTF 26.
yeah, it
That
was
turned
2
into
years
a
ago,
really
right?
interesting playground for the players. Right? Do
Yeah.
you want to mention the.
Maybe we should do another episode of that.
All right,
of
good.
that
I like this.
particular.
We'll save that.
Yeah.
Look for a future episode where
It's a
we look
teaser
back to
for
the
future.
past. But the short version is you had insane things happening in that challenge, where to the point where teams were, if I remember correctly, that was the challenge that allowed a team to pop up a pop-up and a new window in people's. Oh no, that's what they did. So they'd wait until the focus was lost on that tab, and then they would change the window location to a URL where they stood up something that looked like our interface, our team interface for the teams, but slightly different because it had one additional challenge that they had created, a fake challenge that they had a binary in there that gave them a reverse shell on people's machines. So basically, like tricking people with this complex chain into executing this this Trojan horse on their own devices. And like, yeah, that's one of those things you hear about. You're like, well, that's pretty pro level stuff. I don't know if it actually worked, but man, that is impressive.
Yeah, there were some teams that came up to us and said, "Hey, we saw the new challenge, but the port isn't live."
Like, what are you talking about? Which, as another thing maybe we should talk about, we actually had a place where teams were able to leak the names accidentally. So that had happened earlier that CTF. So we were a little freaked out. But, okay, yeah. So web challenges, very difficult, especially if the web challenge allows arbitrary code execution on the server. Plus, depending on how the style of the architecture of how things are set up, if all the teams are hitting the same instance for a team, right, then they can do crazy things of overwriting, or you can have it be a scenario where only the first team through is able to do it because they patch out the vulnerability for everyone else after them. So it creates this crazy, situation.
Isolation is important.
Isolation, incredibly important.
For a challenge that is approachable for everybody.
Right.
Yeah, so I think that this year, the fact that we run different instances for every team made my life easier, because I knew that even if somebody manages to mess up with the Node.js namespace and basically patch or crash or make it impossible for other teams to attack that particular instance, it was an isolated instance and every team had their own instances to attack. So we knew that the game was fair for everybody. So that, CTF organization design choice that was there for the team was actually such a huge advantage for some of these challenges. And it allows you to be more creative, right? So you can do more crazy stuff with your challenge because now you have less things to worry about.
Exactly. So yeah, that's something that we did in DEF CON 28 and we wrote about this on the kind of write-up overview on overflow.io. You can see that we talked about this team interface for the first time, or team instances. So which meant that, so if we have the three teams here, Adam, Alex, and Jan, if Adam and Jan are both attacking Alex's web service, to the teams, it all looks like they're attacking the same IP address and port, but due to some complex, cool magic that our awesome infrastructure people help set up, we actually are each talking to individual, distinct, different backend nodes. So that no matter what Jan does, if Jan DOSes Alex's service and takes it down, it only affects Jan. I can still access it 100% without anybody else's changes or things messing up.
Yeah, luckily in our scenario, I don't know what I'm doing on the web, so it's not as important. But in general, it was a game changer.
That's right? Even worse. If you don't know what you're doing, that means that you're more likely to cause a problem.
So just as an example of me not knowing what I'm doing on the web, one time a friend of mine that is now on, a friend of ours that's now on OO as well, and me spent, I think, 24 hours straight on a web 150 challenge, and we almost solved it. We were very close.
Almost. Awesome. And I'll mention briefly the other thing that's super interesting about prototype parameter pollution. So there was actually, what just happened was Google CTF. There was a challenge called All the Small Things that they had that had a number of various steps. I believe it was that challenge. Yes, that's the one. So the basic idea was they had actually a JavaScript class. This was the first time I've ever seen classes in JavaScript, but you can have private variables in a Java class or in a JavaScript class, which I also didn't know you could do. But it turned out because you could, they deserialized an object from the user, and then did object.assign from that object to the user object, you could overwrite the prototype to then overwrite those private parameters, even though object assign wouldn't allow you to overwrite those things. So, and it turns out that was an unintended solution and approach to this challenge. So yeah,
Nice.
prototype pollution, I think, is definitely an up and coming, let's say, CTF topic area for the web. So that's where the challenge was based around. So then what was the goal of the teams? What did you kind of want them to drive towards?
Yeah, that was another interesting part that I wanted to do was try to make it very difficult for them to patch the vulnerability and have this interaction between the teams where they patch something out and another team manages to bypass the defense mechanism, right? So,
which is, if I can say real quick, this is something that's super important for attack defense CTFs, right? For Jeopardy, you don't even have to worry about patching, right? You may just have the one path that you want them to go down. But here, the whole goal of your challenge was to have it so that there was a cat and mouse game and a attack and defense between the teams, really kind of getting to the attack defense heart of things.
Yeah, because it's important for them to play the game, right? Like not just like, exploit it once, patch it once, and then be done with it. That's in some challenges that's the only thing that you can do. But in this particular challenge, I tried really hard to make it more interesting in a sense of it should be. There should be new ways that they could discover that they could be exploiting the challenge that they didn't think about before. It actually happened very well in the end during the game.
Yeah, and this is something that you obviously can't predict necessarily in advance, but this is something that Jan frequently talks about rewarding players for investing time in a challenge, right?
Mm-hmm.
Yeah, absolutely. So, as you guys have mentioned, right, in a Jeopardy challenge, you go and you download the challenge, you solve it, and you're done. You move on. There might be additional versions of that challenge released for multi-step challenges, and you might benefit from the knowledge, but you're kind of done with that challenge. In a good attack defense challenge, what I really enjoy seeing is this interaction from between hackers. A very good example that I feel is a kind of a formative CTF event for me was shortly after the CyberGrand challenge, the concept of open patching was introduced, or with the CyberGrand challenge, but then it was adopted throughout. So
which means that all teams can see all patches of all of their teams, right?
And this concept opened up a whole possibility of hackers to directly go like into combat with each other. There was one CTF where I was trying to figure out a patch for a service that was actually very hard to patch. The vulnerability was super subtle and super powerful in a way that patching it was extremely difficult without impacting the functionality of that service. And so I came up with a very kind of cheesy patch, which would just change up some offsets so that the vulnerability was still there, but exploitation would fail. In a traditional attack defense, this was often enough, right? It was very hard to actually bypass that blindly. But because patching was open, I created this patch, and then maybe 10, 15 minutes later, I see attacks coming in that are bypassing it. So then I modify that patch. I make it slightly stronger, and then whoever was bypassing my patch, my actual, like, specifically my patch, was bypassing it again, and we kept going for hours. And this was, I felt, a super interesting interaction. Actually, in the CTF after party that year, that was at DEF CON in 2016, I actually found the person
24?
that was directly
24?
24, yeah, I think. Yeah, DEF CON 24. I found the person that was competing with me directly. It was this amazing feeling of hacker versus hacker competition. And with this rich set of, not necessarily multiple, it can be multiple vulnerabilities, but it can also be one vulnerability that leads to a rich set of exploitation scenarios and exploitation space. That we saw, for example, in Node. It's the optimal scenario for me of CTF, where it's really the skill of the different hackers against each other.
Yeah, chump pass versus really good hacker, right?
Exactly. Yeah.
Awesome. Cool. So Alex, did you see any of this behavior during the game? So actually, or maybe you can frame this more around when did the challenge launch in the craziness that was DEF CON 28 CTF?
So we launched it on the last day of the competition,
So 8 hours to
or
go,
eight
roughly.
hours before the end of the competition. And it was exploited, I think, if I remember correctly, it was exploited pretty fast. Like the first exploit was within the hour, I think, within 1 hour, within the first hour, or 1 hour and 15 minutes or something like that, somebody already got a flag
Mm-hmm.
from the challenge. But the interesting thing is that, so let's talk a little bit about the vulnerability too, right? So
Sure.
basically,
Yeah.
through the web application, you could validate the server-side configuration, and there were some default libraries, which are npm modules, that you could use to validate the configuration, which is in JSON. But you could also specify your own module, right? So the restriction there is that the module needs to be installed in the dependencies of the web application. But as we said, Express already installs their 230 different dependencies. So you have plenty of choices to pick from. I also injected some just to lead them on that, hey, there's a vulnerable dependency here, like
Mm-hmm.
out in the blind, completely vulnerable dependency that you can load and use prototype pollution to exploit the vulnerability. I also put another hint in the code that after the request it will clean up the object, and it will basically if you do prototype pollution on the parent object of the JavaScript namespace, it will clean it up so that we make sure that nothing gets too crazy there. But there were other dependencies there that you could be using to exploit the vulnerability. So we saw pretty fast the obvious ones, and a lot of teams picked it up and started using the different modules and the different basically validations in order to load a module and somehow come up with a method to read the flag and leak it out, basically, right? And that happened pretty fast. So I was observing the patches during the game, and I was looking at how people that exploited some of these vulnerabilities patched it, and you could see the obvious cases there. But as the competition went on, people started, exploiting patched services. And every time,
I think one thing on that note that we did in a very interesting way was initially that service was fully patchable, right? You could spot the injection point and create a patch that fixed everything. Once every
right.
team figured it out, or every team that was playing seriously figured it out, then we released an update that made that
Yeah.
no longer be the case, right? And that's when
Right.
this cat and mouse game started.
So yeah, in the beginning they could patch it out completely, and then during the competition we basically improved. We didn't change anything in the code. We just improved how when you patch, we test things out. And basically, the thing that we changed is that we made more complicated validators, so that you cannot just disable the whole validation functionality of the web application. It needs to be there. We're testing something with a validator. But you have to basically come up with a way to block all the exploitable cases of the validation. So basically, this became a very nice game between the teams that they started basically improving their exploits and improving their defenses, submitting patches that blacklisted some additional modules. They submitted patches that they would try to basically see, the generic things. If in the HTTP request there's a name flag, for example, they will drop the request and not serve it, and some heuristics basically to defend against leaving out the flag. So that
It's
was
almost like trying to create a firewall to block things off.
right.
But as we know, that's kind of the interesting thing about this is firewalls are not perfect. And so,
Yeah,
like Jan said, a
web
clever
application
hacker
firewall, yeah.
can figure out different ways to route around that. And that's actually where you get really
Exactly.
interesting interactions and behavior here.
Exactly. Yeah. So yeah, the other cool thing about the should we talk about the fact that in this year we introduced a way for doing stealthy
Yeah.
submissions, because that played a huge role in Node, right?
Yeah, so basically the high level idea is that teams could choose if they wanted to send traffic to a team stealthily, which means the team that was receiving the traffic would never see the PCAPs associated with that request, or they could do it normal where they would get PCAPs roughly 3 minutes later. But if you chose stealthy ports, then for that service and that team, if you stole a flag, you would get half points for that.
I was monitoring that stealth traffic during that game, and Alex, I don't know. Do you want to talk about it? Do you want me to
Go ahead,
say
yeah,
what I
go
saw?
ahead, Jan.
It was pretty incredible. I think what was happening was teams were monitoring the network and understanding which other teams had found which vulnerabilities, and were actually launching attacks, stealth or not stealth, specifically depending on that. We saw one team specifically, Tokyo Westerns, and you can look at this in the game data
overflow.io website. We have a stealth table.
And they had this incredible, like a strategy where over time they change who they're attacking stealthily, who they're not attacking stealthily, and so forth. Which was very cool, and it changed over time. And this was probably the challenge where that was exhibited the most.
Yeah, so I think that's pretty cool, because also like everything is completely visible, right? In a web application like that, you can see all the requests coming in and going out. So if you observe the traffic, it's very simple. It's plain text, right? So it's very simple to understand what they're trying to attack, and immediately blacklist, for example, the dependency that they're using in order to trigger the exploitation, right? So if you have the visibility and you can see the attack coming in, but if you don't, then that's incredibly hard to guess what kind of dependency they're using and blacklist it through that. So we had one team actually,
which I was going to say, then that actually gives, like, incentivizes a team to invest more time in this, because the more things they find and block and patch, the better their defenses are.
Yeah, correct. Yeah. So, and we had, I think, one team that was heavily relying on that, and you know, throughout the whole game, pretty much, they not all of the teams managed to block them, and they did pretty well.
It was Tokyo Westerns that was exploiting over half the teams until the very end.
Yeah, that was a service that we thought was kind of at a steady state, and then things just kind of went crazy as teams. You could actually see them find workarounds and those kinds of things, and we could see it in the flag captures.
Guys, I hate to do this, but I have to go teach. I have one question I'll leave you with that you
Perfect.
Yeah,
we'll finish up for here.
Would Mininode have protected this service?
It would have, actually. It would have eliminated all the unused dependencies. So since all of the dependencies, like the injected dependency that I added that was vulnerable, was not actually actively used by the application, you could just delete it, and then you wouldn't be able to load it. So Mininode would have been successful in defending this Node.js challenge.
There you go.
Awesome. Well, thanks, Jan. I'll take it from here.
I will see you later.
Awesome.
Bye-bye.
Thanks. Cool. So I think the last thing, because we've covered a lot of areas, I think the thing I'm really interested now, because one of the goals that we have with this podcast is we want to be able to kind of use this as a repository to help learn from each other about things that, you know, we could talk about things that we tried and things that we did. So maybe if you could talk a little bit about what you learned from this challenge, and what are maybe some takeaways that, you know, could help other challenge organizers or challenge authors.
Yes, I think I consider at least this challenge to be one of the best challenges that I've designed so far, and I think the reason for that, and that's very difficult to achieve usually, and I have failed multiple times, right? It's not that
I think we all have. That's the first thing we'll all admit is, you know, sometimes you have an awesome idea for a challenge and it falls on its face.
Yeah. So the incredibly difficult thing was how do you make a web security challenge that the vulnerability is kind of obvious, but it's relatively hard to exploit and patch, right? So I think that was the big thing here, that you knew really fast that, hey, the vulnerability, like the application is not complicated at all, right? It has like, you know, 5 files in total or something. That and the paths that are complicated are very obvious, and you can see the vulnerability immediately. But even after you exploit it, it can be really, really difficult to patch it out. So I think that was the interesting spin that I managed to give in this year's attack defense competition.
Yeah, that's great. So that actually goes into philosophy kind of on attack defense challenges, right? There's always this kind of trade-off between, do you do one really interesting bug that's hard to reach and maybe difficult to patch? Do you, because that could be very interesting. The other thing is, do you have several different vulnerabilities where the first couple are very easy to identify and easy to patch, and then you expect as teams get further and further into the challenge, they start patching things? Or like you said, you have a clear vulnerability that is difficult to exploit and difficult to patch, but it's by design almost impossible to patch 100% correctly, and so the teams can find workarounds, and you get this attack defense behavior there.
Yeah, and the high level advice that I want to give to everybody is that it should be, in general, like a good CTF challenge should have a clear goal, right? So once you have a player working on the challenge, this should be, I mean, from my perspective, it makes the game more fun if there are no ways that you distract the player too much, right? It could be the case that it's complicated and they have to reverse engineer a lot of things, but you don't throw, for example, an XSS vulnerability into the web security challenge just to throw them off, right? Or there's no admin visiting the page, but there's an XSS vulnerability there.
Right.
Like, people are going to try, they're going to fail, and they're going to be upset, right? And it's not fun for everybody to exploit something, to find a vulnerability, exploit it, and realize that, oh, that's not the intended vulnerability from the CTF challenge author. We have to find a different way to read the flag, right? That's not fun for anybody. So I think that trying to make the challenge in a way that is focused towards the vulnerability and make sure that there are no other distractions that will basically take away time from the players is a great way to start a web security challenge.
And that's super difficult, though. That's
it's very
kind
difficult.
of the thing
I'm not saying it's
you
easy,
may
right?
accidentally have included an XSS on a page that you didn't really intend, and so that part is really important, really difficult. And that's just one of those things that's you get better and better at over time, but still you can't always. Another way this comes up is binary challenges. You may accidentally have a crash that is beautiful, but that you never thought, but that doesn't allow them to exploit, but it's not not on your intended path. But to tell them they're on the wrong path would probably be not fair, right? Because you don't tell everyone when they're stuck. And I think the other thing that you brought up that's really important, especially in web challenges, can be reproducibility on their side, right? So sometimes that is the point of the challenge. And I know Jan has great challenges that he did for DEF CON 26 quals, which the point was, I think you had a random libc that was used. So you had to figure out, the vulnerability was very trivial, but the idea was, what techniques can you use to probe something blind, right? So there's a challenge that's designed around that. But on the flip side, if you're dealing with, because you happen to use a headless Chrome Puppeteer, but you didn't enable certain options. So, in my browser, it works just fine and XSS's me great, but on your system, it doesn't. And so, I think that's something to always keep in mind of how much information can we give the players? If we're already giving them source, what about giving them the whole thing? There's the whole Docker file, whole container, like similar like you had with Node, right? Here's all the source code. You can run everything locally, test everything locally. And so that way you can reproduce things. I think that's an important thing that I've been guilty of. You often overlook when you're kind of in the crunch of developing these things. But
we all have been there.
It's a good thing for organizers to keep in mind and challenge authors.
Yeah.
Cool. Anything else you want to, leave us with? Thoughts on your DEF CON 28 CTF final experience? Or
no, I think, we covered a lot of stuff. I think as a CTF challenge author, you need also to be participating in as many CTFs as you can, so that you see what other people are doing and be frustrated with things that you have to put on your list, that hey, I should never do
Right.
prototype solution without having different instances for every team and stuff like
Right.
that.
Yes.
So I think it's important to try to always try to be in the position of the CTF players, try to make this an enjoyable game that is educational, and it's fun for everybody, pretty much.
Cool. Well, thank you.
Awesome.
Yeah, Alex, thanks for joining us today. We really appreciate it. So,
Absolutely.
yeah,
Thank you so much for having me.
and all you out there, thanks for joining us today. I'm Adam D. You can find me on Twitter at Adam Dupay. Alex, where can they find you?
They can find me at Kapravel on Twitter.
At Kapravelos, and Alex is currently a professor at NC State. So if you're interested in doing cool cybersecurity stuff in that area,
we have internship positions. You can come and visit for a few months and work on a research project together.
And maybe play CTFs.
Definitely.
Cool. So, and on behalf of Jan, he's Zardus. You can find him on Twitter at Zardus. We're CTF Radio. You can find us online on YouTube and on Twitter at CTF Radio with 3 lowercase O's. You can send us questions through email, ctfradio@gmail.com, CTF Radio with 3 lowercase O's. And who knows, your questions may end up on a future episode of CTF Radio. So take care and happy hacking, everyone.
Bye, everyone.